So welcome back to our second session of today. The first talk will be given by Callaghan, British Atmosphere Data Center. So as I mentioned, the workshop is organized by majorly two projects. One is, let's say, geoscience, prehistoric archaeology. It's SFB 806, which is called 8306, which is called Our Way to Europe. And the second project is on soil vegetation atmosphere modeling. So that's why we're also looking very much forward to hear what the British Atmosphere Data Center is.
Okay. Thank you very much, and I'd like to add my thanks to everyone else's, to the organisers for inviting me here today. And I'd also like to thank you for hanging around and giving up your Saturday to listen to me. I appreciate it. So, as I've just been introduced, I'm working for the British Atmospheric Data Centre. But before I started doing data management work for the BADC, I was a researcher. I trained as a physicist, and my first proper job out of university was studying radio propagation, how radio waves travel through the atmosphere. And to do that, I was looking at how the space-time variability of rain fields impacts radio communication systems. So I have been both things. I have been a researcher who has created large data sets and spent years of my life working on them. And then I have switched jobs to being someone who has to talk to researchers to explain, yes, I know this is really difficult and annoying, but data management is really important. Please trust me on this. And it can be quite a difficult job sometimes. So anyway, the British Atmospheric Data Centre is one of a federation of data centres funded by the UK's Natural Environment Research Council, or NERC. And between all the research councils, or between all the data centres, we cover practically everything you could possibly think of on Earth science. We cover atmospheric science, Earth sciences, Earth's observation, marine oceanography, polar science, terrestrial freshwater science, hydrology, bioinformatics, and we also even get a bit out into space. We have space weather and solar physics. And in the BADC, we have a data set which is Mars atmosphere. So we even have extraterrestrial data sets as well. We only have the one, though, from Mars, although we're hoping to get some more soon. You never know. So, what do we do at the BADC? Our main jobs are to ingest and deliver data, to collect and manage information about that data, to provide data services, and to facilitate science programs. And those science programs range from the really small, one researcher in an office somewhere or out in the field with one instrument, up to really, really big. We are working in collaboration with other research groups on the CMIP5 campaign, which is the Climate Model Intercomparison Project, which is the data from climate models that goes in to provide the results and conclusions that form the Intergovernmental Panel on Climate Change's assessment reports. The CMIP5 archive is running at about 2 petabytes at the moment, and CMIP6 is on its way and is only going to be bigger. So we go from the really big data to the really small data and all the way in between. So when you get to it, you got to ask yourself, why do we need to look after the data in the first place, right? Well, science is all about reproducibility. If you get two people doing the same result or the same experiment in the same way, you should get the same results. This is all well and good if you're working in a lab, and even then it can be quite difficult. If you are sticking a rain gauge out in a field somewhere, the measurements you made yesterday will not be the same measurements as you make today. And you can't just nip back to yesterday to make the measurements again if you lose them, because we don't have working time machines. Which is a real shame. Life would be so much easier if we did. So we need to have access to the data to confirm that the science is valid. We can't rerun an experiment that uses observational data. We need to have access to the data itself, the original data as it was collected. I won't go into this in too much detail because we've already had this mentioned yesterday, and I'm sure that everyone sitting in the audience is pretty much agreed that it's important to make our data open and make it available for others. And it's not just us as researchers who are saying this. There's pressure from government to make data that is publicly funded. That data should be made available to other people to use it because it's good for the economy, it's good for building businesses. The general public whose tax money funds it also tend to want to know what scientists are doing with their hard-earned tax money. Scientists, understandably, want attribution and credit for their work. And of course the research funders want to know that the however many millions of euros they're spending on funding research is actually worth doing. And I don't know why it keeps going forward on me, but never mind. So to encourage people to make their data open, we've got, there's been lots of discussions of carrots and sticks. So we need to have the carrot of a reward. Here, congratulations, you've made your data open, here is a reward for you. Have a gold star, have a DOI, have a citation, have something that will show your boss that you've done good work. As well as having the stick of, you haven't put your data in a repository, you're not getting any more money out of us, thank you very much. That sort of thing. And we need to find the balance between the carrot and the stick as well. Researchers, and I count myself as one of them, we are very, very precious about our data. We have put years of our life into creating these data sets. You create the data set, you then scratch your head and think about it, and then you write about it, and then at the end of the day, it is all distilled down into one slide. And somebody goes, is that it, really? And you go, oh. Managing and archiving data is also really hard work. And most researchers aren't really that interested. They get their results out, that's what they want. That's why we need to have a good relationship with the researchers. The data managers need to have a good relationship with the researchers to work in partnership and make it easy for them and make it easy for ourselves as well, the data managers as well. Data is also a main driver in getting research funding. If you have a data set and you're sitting on it, right, that can make all the difference between your research group getting funding and somebody else's research group getting funding. And because we don't have any universally accepted mechanism for data creators to get academic credit for their work, there's this tendency for researchers to hoard their data until they can extract the maximum publication value out of it. And this is bad for science as a whole. Now, sometimes you will go to a researcher and you say, you should really share your data. And they go, oh, no, I don't want to share my data. I'm happy sharing other people's data, but I don't want to share my own. If you reframe that and replace sharing with, you should really publish your data, they go, oh, I know this publishing business. I get credit for publishing things. I can publish my data and get credit for it as well. I love Lego academics, they're brilliant. But again, researchers want attribution and credit, understandably, and I think they deserve them. So, people have an idea of what a publication is. A publication looks like a book, or it looks like a paper, even if that paper happens to be on a website somewhere. People have a good understanding. You say, oh, I published a paper. They have the same mental image of what you're actually talking about. Data is a lot harder to define. There's DataCite's definition there. A dataset is recorded information, regardless of the form or medium on which it may be recorded, including writings, films, sound recording, pictorial reproductions, drawings, designs, other graphic representations, procedural manuals, forms, diagrams, workflow charts, equipment descriptions, data files, data processing or computer programs, statistical records, and other research data. In other words, if you can think about it, it's probably data. That data could be hand-carved into a whopping great block of stone. It doesn't matter, it's still data. And in my opinion, a data set is something that is the result of a well-defined process. For science data, it has to be scientifically meaningful, and it has to be well-defined. We have to have clear boundaries of what is in the data set and what isn't. Here's some examples just from the earth sciences, and we've already seen the wide range of examples that you get from the other different domains. So from the earth sciences, we've got time series. It's meteorological measurements. Someone stuck a rain gauge out in the field 20 years ago and it's still making measurements now and will still be making measurements however long into the future until it gets broken or sat on by a cow or something. We also have large four-dimensional synthesized data sets, so climate, oceanographic, hydrological, numerical weather prediction model results. Two-dimensional scans, satellite data, weather radar. Snapshots taken at regular intervals. We have a cloud camera at one of our sites which just takes pictures of the sky every 5 minutes, day and night, and has done for years. We also have traces through a changing medium, radiosonde launches. So you launch a balloon, and the balloon carries an instrument up through the atmosphere, and it takes measurements of pressure and relative humidity and other stuff like that. We have measurement campaigns where a group of researchers get together and they bring all their instruments together at the same place at the same time, looking at the same things. And so lots of different instruments, lots of different data coming from all those different instruments, but all at the same time and place. And that campaign actually gives you a better idea of what is happening in that time and place. And of course, we have physical samples. We have British Geological Survey has fossils and has rock cores. The British BAS, the British Antarctic Survey, they have ice cores as well. So this is how we'd like data ingest to run. We would like people to come to us with nicely packaged up data and metadata, which we would automatically just smoothly and without any problems ingest the data into our archive and the metadata into our catalogue. And then someone could come to us and they'd just pull the same data and metadata out again. Oop, wrong way. So a bit like that, except with kittens. But yeah, the kittens go in the tube, they come out the tube. Let's go. What usually happens, however, is a lot more complicated. So I'm not going to go into that in any great detail. Just to say that this is our normal workflow. This is the workflow that we have for someone, the data submitter, who is engaged, who is interested, who wants to give us the data. They're willing to answer questions. They're willing to go back and give us a bit more detail. We do have cases where we have what we call data dumpers. They are people who go, here, take my data, don't ask me any questions, right? And we do our best with that in the hopes that, okay, we'll do what we can, and if it's important 20 years down the line, someone will come along and try and fill in the gaps. So we have preparation phase and ingest phase there. And it involves lots of discussion, lots of talking with the data submitter, writing data management plans for people, and just generally collecting the information, informing them of standards and all the rest of it. And in terms of cute animals with cardboard tubes, this process is a bit more like this poor hedgehog. It gets a bit stuck. Right. So you could say to yourself, well, why do we need all this boring metadata anyway? Here is a couple of really good examples. We've got a Phylum of linear A and the Phaistos disk. These are really old. I mean, the Phaistos disk is 1700 BC. They've been preserved. The data on these things have been preserved for thousands of years. Very well preserved. We still have them. The problem is no one can translate them. People have tried. They get different meanings every time, right? Without the contextual information, without the metadata, we can't understand the data. It's that simple. You could say, well, but everything important is in the journal paper. I would then challenge you to say, does your paper include every last piece of information about the data set, even that time that the rabbits ate your cable that connected your instrument to the data logging computer? Probably not. People tend to gloss over those bits. They tend to say, oh, yes, there was breaks in the record due to technical difficulties. They don't say whether the technical difficulties were pigeons building a nest in your dish or what the situation was. These things are important. Also, people currently don't tend to link the data to the publication that well. They say things like, oh yeah, the data's in BADC, and you look at it and go, where in BADC, what's it called, what bits are you referring to, that sort of thing. So we need to know what's going on. So, how do we publish data? How do we make it open? We can stick it up on a web page. We can put it in the cloud. Anyone who's heard the news recently will know that there's security issues with the cloud and putting things in there, but let's not worry. You could attach it to a journal paper and store it as supplementary materials. Journals are getting a bit more worried about this nowadays. They don't like doing that so much because there's the overhead there. You could put it in your disciplinary or institutional repository. which is what we encourage as we run a disciplinary repository. Or you could write a data article and publish it in a data journal. And I know Hans will be talking more about data journals later on. Journals have published data, always published data in the past. Back in the transaction of the Royal Society, there we have that image of supercells and mimosa leaves back in 1665. And here's, again, other data. This is from the scientific papers of the Earl of Ross, and it's observations of stars in the spiral nebula. The problem is, data sets have gotten so big you can't publish them in hard copy anymore. Here is the hard copy of the human genome at the Wellcome Collection in London. 140 books of very, very small text, right? No one is going to be able to do anything with that. It's there. It's really interesting to see from a perspective, just to look and say, oh, that is an awful lot of information in the human genome, but you can't actually do anything with it in hard copy. We need computers to be able to process and analyze it. So there's a lot of stuff with data publishing and data sharing that gets all kind of wrapped up in itself, and kind of, so I want to pull the strands apart of various kind of different aspects. So we want to encourage researchers to make their data open, persistent, and quality assured. And however you do that quality assurance is disciplinary specific, community dependent, that sort of thing. Well, you could do it through scientific peer review to test the quality of a data set, or you could have repository managed processes where you have automatic machine scanning of files and checking that way. So we have here an example. So in terms of openness, you can have your data on a CD in your desk drawer, and it's not open at all, and who knows about the quality. But CDs in desk drawers, they hang around a lot. Unless they get melted or burnt in a fire or something, you will find them quite a lot. You could put, in terms, if you want things to be really, really open, you could stick it up on a web page somewhere. Persistence, anyone who's ever had a 404 error will know that web pages aren't that persistent. And then also, you find something on a web page, if it's not well documented, you have no idea about the quality. In the middle, you can have a shared workspace. Now, researchers who are a bit iffy, a bit worried about making their data open, often respond quite well to shared workspaces because it allows them to collaborate with their colleagues without opening it up to the wider community. And it's kind of a baby step between full openness and kind of keeping the data completely locked down. So that can be quite useful for people to reassure them. So, open access journal is open, obviously, the clue's in the name. It also has commitments to persistence and some quality control processes that it's been through. A subscription-based journal has similar quality control and persistence requirements, but of course it's not open. And data repositories, whether they're institutional or discipline-specific, tend to kind of sit in the middle. We make we can do openness, we can also do quality, and we also make certain persistence statements. Hans is going to talk about this in a bit, but just to say that publishing with a capital P is publishing, is making something public after some formal process that adds value for the consumer. So there's a commitment to persistence, and there is some process that adds value. So there could be peer review, for example, or some other quality control. So here we have a data set published by the BADC. We have made long-term commitment to long-term persistence for this. And you can see there that green, don't do that. That green oval there shows how you cite the data set. And when you go to the download button up the top, you click on that and it will take you into the BADC archive where you can actually download each of the files. So, citing data. we want to encourage people to cite our data. We want to encourage that link between data sets and publications. And the easiest way we can do that at the moment is by encouraging researchers to cite the data in exactly the same way that they would cite another research paper. And the reason this is good is because researchers don't have to learn a new method to do anything. They just treat the data exactly like a research paper. And also we can piggyback on those citation indices systems that already operate to give us metrics and a way of counting how much of an impact something has. So, has anybody heard of the Joint Declaration of Data Citation Principles? Anyone? Oh, a few hands, that's good. Right, anyone who hasn't heard of them, please go check them out and also sign up and endorse them. These are all, the main 8 principles are there, and they are all pretty much what you'd expect. It's all about the importance of data and how data citation should be used to support that importance of data. So, go and endorse them. So, I kind of think about the process of ingesting data all the way through to data publication, and there's kind of 3 levels. We start off, and we serve our data sets. This is our day job. We take data in and we create metadata and we collect metadata. And we make sure that there is adequate metadata and that the data files are in an appropriate standardized format that works on community standards. And then we give the data out to other people. Now, these data sets that are being taken in and given out are often being updated all the time. Wrong way. So we've done that. So data set citation is drawing a line around a data set, saying this data set is complete, it is fixed, it's not going to be changed. You can cite a data set that's being updated using a URL. That's fine. You can cite a data set that's frozen using a URL. It's just researchers and people tend to be more trusting of DOIs. We also load DOIs with more meaning than the fact that they're just a simple permanent identifier. We use them to signify that the data set is complete, and also to make some comment about the technical quality of the data. In our opinion, in the NERC data centers, when we assign a DOI to something, we are saying, yes, this is complete and it has sufficient metadata that it's going to be usable in the future. So, publication of data sets isn't so much something that's required for the disciplinary data centers, but it's for institutional repositories who don't have the discipline-specific knowledge in-house to be able to evaluate the quality of the data set. And that's where we partner with the journal publishers to bring in peer reviewers with domain knowledge to be able to comment on the quality of data sets. So one of the ways we do this is we talk about data journals, where people write a data article, which is just a fancy human-readable collection of metadata about the data set, talking about the when, how, and the why the data was collected and what the data set actually is. And then they write this article, they link it using a DOI or some other permanent identifier to the data set, and they submit it to a data journal where the data paper or the data article and the data set itself get peer reviewed. And then this data article and the data set are put out as published works. So therefore the researcher who created the data set gets the credit that they deserve for making the data available. And again, Hans is going to be talking more about this later on, so I won't talk too much. So there's also this trend for enhanced publications where you have a normal research analysis paper, and there's the push towards citing the data that was used in that analysis paper. So you connect the analysis paper with the data set. And you might get people asking, well, why do I need to publish a data paper? Surely everything's in the analysis paper, why not just publish in a normal journal paper? So data journals, they do more things than a normal analysis journal would. So data journals can peer review the data. You can also publish negative results in a data journal because data journals accept a data set as it is. There is not really a concept of good data and bad data. There is data and whether it is usable in the future. a data set that could be absolutely rubbish for the experiment that it was designed for could be really, really useful 20 years in the future. So an example that I have is an example that Kevin gave yesterday, radar noise. That was from, I can't remember what the instrument, it might have been meteorological radars or something like that. But the noise was actually the dust from a volcanic eruption and how that was transported. So as far as the radar scientists who collected the data were concerned, that data was absolutely rubbish, but it was really useful for other people. With a data journal, you can publish things more quickly. If you spend 2 years of your life collecting a data set, you don't want to spend the next 2 years of your life analysing it before you release it out and make it available. So you publish the data set as it is. You don't have to do the analysis stuff. It gives you attribution and credit for the data collectors who might not be involved in the analysis. And also it makes it easier to find the data sets and understand them and have an idea of what the data actually is and how easy it will be to use them. So here's an example of a live data paper in the Geoscience Data Journal. And in this particular case, the data set citation is the first thing in the paper after the abstract. And the data citation is also in the reference list. And that allows it to be picked up by the citation count systems that are around. So we mentioned data metrics yesterday. We collect lots of metrics about the people who download our data and what they download and when they download and where they are and all the rest of it. That is all well and good, but as soon as somebody has downloaded our data, we do not know what they do with it unless they come back and tell us. Right. We're pushing data citation because that will give us some idea of citation counts and some idea of what people have done with things. But it's not common practice at the moment. And we don't have reliable data citation counts yet. Although we are working with DataCite and Thomson Reuters to be able to get these data citation counts. So if we want to find out how BADC data is used, we have to do this process where we search in Google Scholar for BADC, scan the results, pick out all the ones we think are the right ones. Then we have to read the paper to figure out what data sets the authors are talking about. If we can, there's a lot of papers out there that says this data comes from the BADC, and it's what data? We don't know. And then we have to count them. It's not easy, we don't do it very often, I have to say. We want an easier method because we need, as repositories, to show our impact as well. So, the Research Data Alliance got mentioned yesterday as well. There is a working group on bibliometrics, publishing data bibliometrics, which I'm co-chair of, and we have launched a survey, which is still live, asking researchers, asking anyone who's interested in metrics for data about how they would like to evaluate the impact of their data. So if you are interested, please go and fill out the survey. If you're really interested and really keen to get to know bibliometrics for data, please come and talk to me and join the group as well. We are an open group. We are always willing to have new members. So just quick final things. To a certain extent, the disciplinary repositories have it easy, right? Because we can pick and choose what data we keep, we can ask for and get more detailed metadata, and we can provide specific tools and services like visualization, server-side processing, and we can also deal with the big data in our particular domain. Libraries and institutional repositories have the difficulty of dealing with everything that's left. They have to pick up and manage and archive the long tail data where there isn't a domain repository. And they're going to have to cover everything from astronomy to zoology and everything in the middle. And to do that, they're going to have generalized, widely applicable systems that can cope with all these. And they have to be able to cope with anything. So libraries and institutional repositories won't be able to get the rich data that the domain-specific repositories can. So I really feel like there's a synergy. We can work in partnership with institutional repositories to make all our lives easier. So, quick sum up. We wouldn't be here if we didn't think data was important. Data is becoming more important to more people. Policymakers, government, the general public are even getting interested in data. They want to know what it is and how they can use it. Of course, science, you can't test your conclusions if you can't get access to the data. And if you can't get access to the data and you can't test your conclusions, you can't reproduce the results and you can't verify them, and then it's not science if you can't do that. And it's everyone's job, every data manager, every researcher who creates data, it's up to us to care for the data we've got and ensure that what we did to get that data is transparent and understandable so that other people can use it 20 years in the future, but also so the researcher who created the data set will be able to remember 10 years from now what they did. People's memories aren't that reliable, and everyone needs to write things down. And also, we need to make sure that people can trust our results. We are open, we are transparent, we are understandable. So finally, one final thought. We share our data, we make our data available, we publish it, we publish our results because we are scientists. We are not alchemists beavering away trying to find the secrets of eternal life. We don't hoard our data, we don't hoard our results because we are not alchemists. Thank you very much.
Thank you very much, Sarah. Are there any questions? I again have a question. So it seems that data matrix and linkage of data publication to journal publications seems a tool to maybe motivate researchers to provide data. So many, personally I also criticize, of course, the H-index and the citation community, and we already discussed this at Coffee Break. It's also a lot about networking and how you design a network, a citing network or something like this. So, but it still seems to be a measure. Do you think the data matrix should be organized and provided by the editing houses like Thomson Reuters, which you mentioned, or should it come from the science community?
So, Thomson Reuters are selling the Data Citation Index as a service. They're selling this. It is a commercial product. I think that, yes, we as a scientific community should self-organize and come up with an open metrics. So the survey that I mentioned earlier, we are looking at things like alt metrics and everything we can possibly think of. We're casting the net wide to try and figure out what new things we can do to quantify the impact of data. There is a lot of kind of discussion along the lines of, well, H-index is broken, we really shouldn't be doing citation counts anyway, do we really want to be applying these broken things to data? Unfortunately, until we change scientific culture enough so that we can have something that works, that is an accurate representation of the impact, we're a bit stuck. Funding bodies and the people on promotion and tenure committees are always going to want some number or some easy thing that they can point to and go, oh, person X is better than person Y because person X's number is 27 while person's number is 2, person Y's number is 2. That's what they want. They want an easy way to differentiate between people. And as soon as we start reducing people and scientific output and research to numbers, we're going to have problems like that. It's an issue. It's a sticky issue. It's not going to be solved anytime soon, I don't think. But we're working on it. People are looking into it.
That's exactly what many people think. Also, the idea of the, let's say you call it rubbish data or something like that. They can also provide this data. This is part of a huge discussion in Germany when we changed from the old system of having a PhD thesis as a monograph to the now very modern system to have a paper thesis based on maybe 3 or 4 SCI-based publications. And exactly the critics always on the new system is that if you write a PhD thesis as a monograph, you can also provide information on your try and error maybe system which maybe end. And this is very maybe valuable to the science community. So someone else maybe does not have to follow the idea. But you would be never able to publish maybe not very nice R-square experiment in a paper. It's changing now, but usually that's the case. So I like this very much, and it's, I think, extremely important.
Negative results are really important. We need to be able to learn. It's not enough to learn what somebody did to do it successfully. We need to know what they did and it failed, because otherwise that's going to be horribly inefficient. You're going to try doing things that other people know don't work. So yeah, publishing negative data, publishing all the things that went wrong. We need to be able to learn from each other's mistakes. And you're right, the journal system at the moment only publishes the highlights. You don't get all the kind of false paths and dead ends that happen as a natural result of doing research. And there's a certain feeling that I have that if you're not making mistakes in research, you're not doing research. You're just kind of going down path you know will be successful. You're not actually branching out and trying to discover something new.
I also think, of course, that we need something to measure the data. And of course, I have heard several ideas from scientists and so on. Let's say we have a simple approach like, I don't know, Facebook, but that the researchers can like the data.
Yes.
Do you think this could be a procedure?
Yes. There is an EU Framework 7 project called CHARME, C-H-A-R-M-E, which is looking at doing annotation metadata. So you have a data set in an archive and they have a CHARME plugin where basically you can do things like add an annotation to a data set saying this data set was cited in this paper. Or you could draw a little box around an area of interest in a plot to say that, oh, this area, and then you can annotate that to say this area in this plot is interesting because blah, blah, blah. And then you can get dialogue going on through that. Now that's a less formal way of doing discussions about data than you would get potentially in a data journal. And Hans, you had something to say about that.
I must object, of course, if I may. Because Georg and I had a discussion over coffee just half an hour ago, how the current system is being gamed. It's a nice idea to help people, let's say, discover interesting data by annotation, etc. But as soon as you introduce these numbers or metrics or whatever metrics into evaluation, people will begin gaming the system. And it's just too easy to buy 1,000 likes. You can do that today for $5 or so. It's much easier to buy these social media attributes than buy yourself a favorable peer review or whatever it is, however flawed that system is.
Yeah.
I just would argue, okay, metrics might be a fine thing if it were not for the abuse in evaluation.
All metrics are going to be gamed, though. That's the nature of how it works. I mean, H-index is gamed.
If they're used for evaluation.
Yes, yeah. I think the difference, Facebook is a commercial company. They make money. If they will make money however they can, whether that's selling likes or whatever, or selling advertising. Then again, it's up to us as a community to come up with ways that, well, at least nominally, we'll have the integrity of saying, no, we will not sell likes on our particular system. CHARME isn't a commercial system. As I said, it's a Framework 7 project. It is purely annotation based. We'll have to see when it gets rolled out, when it gets rolled out, fingers crossed, whether it does get spammed or gamed like that. But we don't know at the moment. But we've got to try something.
So I do not see any further questions, so thank you very much.
Thank you.